So welcome to the walkthrough for Edexcel Higher. It's paper 1. It doesn't say the date, but trust me, it is summer 2022. Here we go. Number 1, standard inequalities, but just treat it like an equal sign, just do opposites. Do the same to both sides, however your teacher normally describes it. Setting up, add 27 to both sides, dividing both sides by 7. Onto prime factors. Unusual that they give you a prime number this high. It's quite a strange number, 124. But if you don't recognise a number, halve it. 62, also less familiar. And that's why it's a strange question. It's a 31. So you could write 31 times 2 times 2. But I'll stick with 31. I'll do it in index form, just in case they ask a different question. Number 3. So delivery, wordy, wordy, wordy. At the end of the day, the question is about cars and petrol. So it's really the cars we're interested in. So 3 out of 10 shares of the vehicles are cars. Of means times. So 160 divided by 10, 16, trebled. So 48 are cars. 1/8 use electricity. Divide by 8, you get 6. 25%, that's a quarter, use diesel. The rest. So rest means all those, take them away. 48, take away 18. Scroll all the way down because they're giving you way too much room for this question. For 30. Number 4, standard form questions. Really, write this, and on we go. So, minus power means small number. Move the digits to the right. -3 means divide by 10 3 times. Or if you're a decimal point mover, feel free. As long as you get the decimal point in the right place, no one cares. This one, it's not large, but you know what I mean. It needs a positive power. If you want to do the counting, 1, 2, 3, 4, 5 times it moved. Up we go. Part C, we haven't got a calc, so do the numbers first, 4 sixes, then add the powers. 3 added to a det of 5, det of 2. You've earned a mark, but it's not in standard form. The 24 needs to be divided by 10. And so to balance it up, you multiply this by 10. Or in other words, add 1 to the power. Number 5, a couple of ways you can go about this. You can go internal angles if you want, but I'm going to go for external angles, chopping it in half. So you've got a hexagon. So 300 divided by 6 means the external angle of a hexagon is 60. 360 divided by 5 means the external angle of a pentagon is 72. That tells you all you need to know. Add them together, 132. I've cheated for number 6 because me and the electronic pens, they do not mix. But I have left room for the explanation, so this is cut and pasted from my worked answers. So when it comes to completing the table, when you know it's a quadratic, you should always look for lines of symmetry. Always start by subbing in positive numbers first. So I'll start with 2 to see if there's any symmetry. So 2 squared is 4. Take away 3 2s means -6 is -2. Add 1. We've got symmetry. So there's a line of symmetry there, and we can rebound the 1 here. So if you work out this one by doing 4 squared is 16, take away 3 4s plus 1, we get 5. That will reflect down here. Obviously, when you plot them, smooth curve going through all the points. When it comes to the solutions, as you can see, solutions means roots, which means where does it cross the x-axis? I'm getting something like, as you can see, just over 2.5. So I'm going to call that 2.6. And I'm getting something just to the left of a half. I'm calling that 0.4. They're actually the spot-on answers. The mark scheme allows up and down by 0.1. So 0.1 tolerance for that. Number 7. Cube A. Let's focus on cube A. Cube A is 3 by 3 by 3. In other words, has a volume of 27. B, 6 by 6, sorry, 4 by 4 by 4, 64. Got 6 on the brain. So to work out the density, all right, let's not forget DMV. Density is mass divided by volume. So for A, it's 27. Whoops, it's 81 now. 81 divided by 27, it's 3. B, 128 over 64, it's 2. So it's 3 to 2. Next. Estimating the mean, non-calc, but friendly numbers. So first of all, list your midpoints. They're evenly spaced. So it's starts at 5, going up in tens. Middle, middle, middle. And multiply them by the frequencies. 5 eighths are 40. That's 150. 425s are 100. So that's 175. 235s are 70. And that's 135. So your mean, if you want to use a bit of proper terminology, back when I was a lad, sigma fx is your total of these numbers. I've added it up in my head, hopefully 570, and that should be nice because sigma f, the sum of the frequencies, is 30, and 57 divided by 3 gives us a nice friendly number. Number 9. A couple of ways of going about this, because essentially the bit of the large cube that is chopped out reappears up here. So you could argue that you just do the large cube and don't worry about the bit that's cut out. And when you do the small cube, don't worry about the top, because this up here is that down there. So I'm going to go about it that way. So the small cube, it's 4 by 4, which is 16 per side. And we're ignoring the top and we can't see the base. So there's 4 sides, 64. And now we treat the cuboid as if it's not got anything on top. So we do the side, that's 6 5s. The base is 7 6s. And the top and the front and back, is 7 by 5, 35. So we've got the 64. That's the small cube. And then we've got the 30 needs to be doubled, because if there's a right, there's a left, and so on. 35 needs doubling. 42 needs doubling to 84. And if we get all that added up, what we get in 278, I think. Sounds about right. Number 10, cumulative frequency is so easy. I've done it already. Add it up as you go along. And I've had a go at it already. But I will talk us through. Now, don't forget, you must use the upper class boundaries. So you must make sure you plot the first one at 50 along, not 25. Second thing to be careful of, they've been sneaky here. The horizontal axis and vertical axis don't have the same scale. Vertical axis is 10 little squares for 20, so each little square is 2. And horizontally, it's 50, so each little square is 5. So part C. less than 125. So I've done it in green. Find your 125. As you can see, it's a couple of squares below. All right, I've got a couple of squares below 40. So mine's looking at something like 36 or so. Mark Scheme reckons 35 to 39. So anything in those regions inclusive. Then we go to the purple. Yeah, let's change the pen to coordinate. So lower quartile is at 25. Now that's actually in the table, so that's definitely bang on 100. Upper quartile 75. So as we know, the horizontal, it's just over 5. Okay, so it's about half a square, so it's about 7.58 below 200. So it's about 192. So I'm getting 92 for my interquartile range. Mark scheme, I'm at the upper limit of the mark scheme. They say anything from 85 to 93 inclusive. Number 13. So good old wordy ones here, but actually not as bad as the words might tell you. Let's not forget, probability is number of ways you can be successful. So a lime sweet is 9 shares over the total possible outcomes, 9 plus 4 plus x, simplified, equals 3/7. That's why it's hella wordy, but it's only worth 3 marks, because you've got an equation. Let's times both sides by 7, and both sides by x plus 13. Subtract 39 from both sides, and we get what sounds like a reasonable answer, so we can be very confident that 8 is correct. Number 12, you can almost guarantee they're coming up on your usually non-calc, but they love these questions, don't they? So just get used to it. Let x equal the decimal. We want to budget up so that the decimals recur straight after the decimal point, like so. And we want to bunch them up again so that it ends in exactly the same. And because it recurs every 2 digits, we need to multiply by 100. So we go straight, we go straight to 1000x. We do our old giant takeaway, bottom minus the top. 117 point splodge, take away the 1 point splodge, 116. So divide both sides by 990. It does not say cancel down or show it in a particular form. It does cancel down if you halve the top and halve the bottom. But either of those two answers are perfectly acceptable. So it's Pythagoras, but with circles. You might have even seen these videos. There are people who've done it on various websites who've demonstrated Pythagoras works with circles as well as just squares and other forms as well. So let's just remind ourselves that if we want to do area of circles is pi times the radius squared. So if we let the radius if we let this length be a, the radius will be a over 2. Same here and same here. So area of region A is going to be pi times the radius squared. But it's not a circle, it's a semicircle. We need to halve it. We need to do the same for B. So it's a half pi times b over 2 squared and a half pi c over 2 squared. All looks very complicated, but you can probably tell loads of stuff will cancel out. So speaking of which, let's get rid of the pies. And a half squared is a quarter, so everything's going to be in terms of eighths. So it's a squared over 8 equals b squared over 8 plus c squared over 8. And obviously, timesing through by 8 gives us what we know to be Pythagoras. That's all it wanted. It doesn't want you to go through actually testing Pythagoras, or you could, if you wanted to go a bit further, do a squared plus. Doesn't matter. That's enough. That's all the examiners want to see, that you've used pi r squared and everything's multiplied out and cancelled and so on. So number 14, yeah, we've got another one where I've cheated, otherwise I'll be drawing that on all day. I've tried to pick numbers where it fits in nicer, because it is an estimate, so you can just sort of play around a little bit with a see-through ruler. But I always try and get a whole number involved, and there I have there. So the height of my triangle is 4, and the width is 4 and a bit, 4.4. So gradient is height divided by width. And obviously, I've got to tidy this up a little bit and earn our marks. It's 3 marks, can't just get it for that. So times top and bottom by 10, divide top and bottom by 4. You might know 10 elevenths is 0.909 or whatever. In other words, 0.91. If you didn't know that, 11s into 10. Wouldn't take you too long. It's 0.909 recurring and so on. What does the area under the graph represent? No need to fill up 2 lines. It is just the distance travelled. Number 15, vectors without a diagram. So I'm going to take AC and take a 3 out. That's the key to that step. Prove that A, B and C lie on the straight line. Well, as you can see, they have the same, you can call it gradient, you can say or whatever, but because one is a multiple of the other, you can make a little statement that they are parallel. They also both start at A. And if you've got 2 parallel lines that start from the same place, they are on a straight line. So put in your own words, don't overcomplicate, all right, but that's all you need for those 2 marks. D's a weird one. You can tell they've given you enough room to try and think. So if you've got D to E, like that, negatives mean opposite direction. So E to F would be like that. So as you can see, it's a much shorter distance. Okay, so you need to, doesn't matter where the negatives are, by the way, you can do one minus the other, it's entirely up to you. But if I did, 1 plus the other, so 3 added to negative 10.5 means we'll get that distance there in terms of E and F. So that comes out at minus 7.5 E. 6 take away 21 is minus 15F. Now, as you know, in vectors, minuses don't really mean anything because it's just opposite direction. So in terms of whether things are parallel or whatever, we know they're parallel because they're multiples of each other. All right. So because it's negative 3.5 as you multiply, by the way, I don't think I mentioned that earlier, minus 3.5, but that's not the answer. So if we take out the minus 2.5, you can actually see it's a multiple, but it's in the opposite direction. Let's not worry about direction. At the end of the day, the line D to F is the biggest, and it is 2/5 bigger. it's negative 2/5. But you know, in terms of we're looking at absolute size, not direction. So if something has a multiplier of 2.5, it needs to have a number which is 2.5 bigger. So when it has d to f first, your ratio could be 2.5 to 1 because it needs to be d to f is the longest side, it gets the bigger number. If you want to tidy it up and double them both, 5 to 2 will also be a good answer, it'll suffice. Number 16, they've given you all page for this. Why is that? Because you don't have to, you can draw a probability tree, and I think it is best explained. So we're going to say that this is theory, and this is practical. We've got a pass, which is 0.75. So we've got a fail, which is 0.25. We've then got more passing and failing. Passing and failing. Now what we do know, all right, is the probability of passing only one of the two parts. So that's this, that's pass-fail, and then we've got fail-pass. Those two add up to 0.36. But as you can see, we have no probabilities on the second sets of branches. But you do know one important fact. They add up to 1. So if we call that x, that's 1 minus x. And they could be the other way around. Doesn't really matter as long as you check right at the end. So the idea is that the pass-fail branch is 0.75 times x, that's this branch there, added to 0.25, 1 minus x is 0.36. So you've now got away from the probability tree, you've got some algebra. So we've got 0.75x, take away 0.25x, and we've got 0.25 when expanded, take that away from both sides. So I'm getting double both sides, x is 0.22, but that's not my answer, because it did ask the probability of passing the practical. So it actually wants the probability of the top branch, x I happen to have put on the bottom branch. So obviously it would have been easier to put the x on top, but never mind. Number 17, double proportionality, algebra based. One thing at a time. So y is directly square root of t. We stick in 15 for y. We stick in t equals 9, square root of 9. So we get k is 5. So we've got a formula. Similar to over here. Y is inversely proportional. Whoa, what a hell of a k. Inversely proportional to x cubed. In goes t equals 8. Alright. It wasn't a y, it was a t. Dafty. Worried too much about my k. Over x cubed. In goes the 8. 2 cubed is 8. So you can see that k is 64. So that gives us our second formula. Whoops. I'm on one today. Rubbish. It asks, find a formula for y in terms of x. In other words, it wants t gone. So sub it in. y equals 5 square root. Replace the t with all this nonsense. Now, when you square root a fraction, you square root the top and square root the bottom separately. If we square root the top, we get 8, but don't forget it's multiplied by 5. If we square root the bottom, you could write as a fractional power. I'm not going to bother. Doesn't make life any easier for me. And there we go. Number 18, trickier, laws of indices, but can't really do anything until they are top-heavy fractions. Improper. So big times bottom plus top gives me 49 over 9 to the power of minus square root. 4 times 2 plus 2 gives me 14 thirds. And on the bottom, 2 to the minus a third, bring it to the top. It's 2 cubed. On we go. Negative means flip it, so it's 9 over 49 square rooted. 14 over 3, nothing to tidy up there. 2 cubed, we'll call it 8. Over 1 if you want. The 3's cancel. Divide 14 by 7 and 7 by 7. We're getting top times top, bottom times bottom. As always with these horrible looking questions, they always work out quite straightforward. Number 19, got a choice on this one. You could combine as a single fraction, etc. It's entirely up to you. I prefer to think of it as I've got a term and another term equals another term. I'm going to multiply every term by 2x minus 1. So here it disappears. Here it goes to the top. And here it also goes to the top. Then we multiply everything by x minus 1. Appears up here. Cancels out here. Appears up here. Now it's a matter of expand and simplify. Let's expand first. X minus 1 plus 6x minus 3. Forget the 1, just expand the brackets. 2x times x minus 1 times minus 1. That loop is minus x minus 2x. And if we're going to solve, you need to make it equal to 0. So I'm going to keep the x squareds where they are. So negative 3x, we've got positive 7x over here. So take away 7x from both sides. Got minus 4 here, so add 4 to both sides. Now you can see the form it wants it in, so it could be complete the square if you wanted to. It's definitely not factorise, but I'm going to go for formula, where a is 2, b is negative 10, and c is 5. So minus b becomes positive 10. B squared is 100. Minus 4 times 2 times 5 is minus 40. All that is 60. All over 2a. So this root 60, let's have a little look at it. It's got a square number that goes into it. Daft. In other words, it's 2 root 15. So every term on the top and bottom, and that's also the reason why there is no number in front of the radical there, because it disappears. All these numbers are even. Halve the 10, halve the 2 root 15, halve the 4. On we go. You kind of know they're coming. They love these circles questions. It's always coming up on one of the papers somewhere. But it's not the worst. And I wouldn't even advise drawing the circle. You can draw the diagram to get a picture of it. You know what circle looks like. You're told that the centre of the circle is -1, 3, so it's like that. And 6, 8 is somewhere up here. But as I say, if you wanted to draw the circle, feel free, but not bothered. You want the radius in terms of how far along is it? It's 7. How high is it? It's 5. Do it by counting from -1 to 6 and 3 to 8. We want the gradient of the radius, and that is vertical over horizontal. Now, as you know with a tangent comes in, I've done that rubbish, but that's a perpendicular. So the gradient of the perpendicular, negative reciprocal. Change the sign and flip. Now, on a lot of my other videos, I go into using y equals mx plus c for this, where you sub in the radius, the value x equals 6 and y equals 8. But I'm actually going to do this one a little bit more of the A-level route. If you haven't seen this formula before, it is very handy. And if you're going to go to do A-level maths, you'll use it till you're sick of the sight of it. It basically means y minus the y coordinate equals the gradient x minus the x coordinate. And now we tidy it up because it wants it in integers equal to 0. So times everything by 5 to get rid of that. While expanding the brackets, -7x, +42. And it wanted it with a 0 on the right-hand side, so we'll do as we're told. We'll add 7x to both sides. We'll subtract 42 from both sides. And there we go. So circle without the circle needing to be drawn. And finally, we've got this doozy. I remember this coming up. My class absolutely hated it. And that's because it's got so many steps to it. Let's do the easy bit. Now, if you do struggle with these sort of questions, at least get a mark, at least do the easy bit. Circle B, the middle circle, well, I know they're all circles, but it's circle B we're looking at. All right, circle B has a radius of 4. So it has an area of pi r squared. So at least get a first stage ticked. Now, what else is there? Well, let's get into the meat and drink of this one, the real tough bits. We need to do 16 pi, take away these two. They're like intersections of a Venn diagram. There aren't formulas for them. You need to deconstruct it. There are, I'll delete these in a sec, there are 4 equilateral triangles. Let's focus on one of them. They're equilateral because A to B is 4, A to the edge is 4, and B to the edge is 4. So it's 4 all the way around, and there are 4 of them. So, what is the area? As we know, with area of non-right angled triangles, it's a half times A, which is 4, times B, which is 4, times the sine of the angle between them. It's equilateral. It's 60. So a half times 4 squared is a half times 16. So we've got 8. And sine 60, or sine 30 is a half. Sine 60 is root 3 over 2. So in other words, the area of one of these is 4 root 3. Now we'll need that when we put all the pieces of the puzzle back together right at the end, but we'll also need it for the next step, because what else is there? As you can see here, I'll just use a different coloured pen. I'll go for a bit of a lighter orange. We've got this segment here, and it's repeated here. And there'll be another 2 there, 2 there, and 2 there. So in other words, these little segments, there's 8 of them. So we know there's 4 of these. This one's going to get times by 4 in a bit, just not yet. So let's get rid of some of this bump. Let's keep the segment in. The segment is basically a sector with the triangle cut out. The sector, the formula for the area of a sector is the angle involved out of 360. It's x over 360, lots of pi r squared. That's the area of the slice of cake. But we want just the bit at the end, and as I mentioned, we need to take away the area of the equilateral triangle that's inside that slice. So let's tidy this up a bit. 60 over 360 is 1/6. 4 squared is 16. 16 over a 6 cancels down to 8 over 3 pi. We haven't got a calculator, so we have to leave it like that. So we can now make this massive step. Let's not forget the original area of the whole circle while I scroll down to give myself some space. Let's get a different colour. Let's go for red to show we mean business. So you've got to say that the area of the shaded, and this is going to be a long line, is the whole circle, which is pi r squared. We have to take away 4 lots of the triangle. So 4 lots of 4 root 3, 16 root 3. Then we have to take away 8 lots of this. So let's times everything through by 8 as we go. And let's also, because the minus, change the sign. So this becomes negative 64 pi over 3. We've times it by the 8. We need to multiply this by the 8. Don't forget we're taking it away. So it becomes minus of a minus plus 32 root 3. So it wants the answer in terms of pi. So as you can see here, we can get the surds out of the way. They're of the same kind. That's nice. Negative 16 of something plus 32 of something means you've got positive 16 of something. Now we need to tidy up these pies. Now, I've checked the mark scheme. You actually don't have to. They allow it in unsimplified terms, but all right, let's finish off on a high. Let's show you how to do without a calc. First of all, ignore the pi. It's the fractions we're interested in. 16 is really 48 thirds. And here is negative 64 thirds. 48 minus 64 is negative 16 thirds. As I say, folks, not a nice question. You can tell it's on there to absolutely. I thought an earlier paper, the November paper, had some right easy stuff at the end. This one, not so. I do remember my class coming out. Yep, they weren't happy with that, but what you've got to try and do on these questions, if you don't necessarily get 5 out of 5, ask yourself, where can I get some marks from? And you might be able to have just thought about equilateral triangles, segments, sectors, and try and blag your way to 2 or 3 out of 5. Because, as I keep saying to my classes, avoiding 0 is sometimes the big success. Anyway, heck of a non-calc paper that. Thought it was okay at the start and a couple of dodgy ones at the end. But I hope that helped. See you on the next one.